All right, so I wanted to make a quick video for you guys on how to work with Docker and Apptainer to be able to use the stack on your own systems. If you'd like to try that, give me just a minute to get the screens set up here. So make sure that we're seeing what we need. All right, so should be visible here now. And so I'm going to give this a whirl. Actually, nope, seems like it's, well, I think that's right. Yeah, it's showing me. All right, so hopefully you guys can see this. I'm going to try to walk you through just a couple of steps. I can't give you everything that will work in all situations and all scenarios because there are too many differences between different devices, different computers these days, different chips. The Apple chip change some things a bit. So your mileage will vary, but I'll give you the overview of all steps that I know are in common for the different operating systems, Windows, Mac, and for Linux. And then we'll kind of review and look at some spots where you may need to make some changes. And if you need to contact me with some questions about how to polish it up and get it working for your particular system, make sure you email me or contact me on the Discord. So when you're trying to put this stuff together, most of the things that you need to know will be under the materials section. Of course, we always have our ability to log into BioSim or the VM host. These are just our two clusters that run the stack. And we want to try to emulate that environment on your own system. So if you jump into and log into our JupyterHub systems and start your server over there, the whole idea is we want to be able to get this whole stack that you're usually using on the JupyterHub systems, and they're always accessible on the web. That's your common denominator. Even if things aren't working on your machine, always log into these systems and finish your work there. But if you want to get it working on your own machine, we need a couple of tools. So I'll come back and kind of look at this in just a minute, but for now, just keep in mind that's what we would be connecting to at JupyterHub, and that's all running on our servers here on campus. So to be able to get that environment in your own system, you're going to need Docker. And just to start with here, so this is the Docker system itself. So I'm just going to kind of point out where that is, right? So I recommend if you're running Linux to install the Community Edition. So these are, I don't know, these are different versions here. They've kind of changed the link, so I've got to update all that again. So maybe let's just start at docker.com to be able to get started. So if you're running on Windows and Mac, you'll probably want to go with Docker Desktop as your installation. They're pretty straightforward. Just make sure that you choose the right chipset for your device. Most of you will be Windows AMD 64, but then for Macs, it depends. If you have a little bit older Mac, you'll take the Intel chip. If it's a little newer, you'll do the Apple Silicon chip. And there may be some flags that you need to use when you're trying to run Docker that will differ from what you see me do. But you should just be able to download and install Docker Desktop and follow the instructions. There is Docker Desktop for Linux, but I recommend if you do want to go with Linux, instead, I don't recommend using Docker Desktop. I instead say, go to developers, go to getting started, and they'll say learn how to install Docker. And here are all the Docker Desktop installation instructions. But instead of doing desktop for Linux, I would recommend you just install Docker Engine, which is the open source command line client. And it doesn't involve some of the extra features that are there, but the desktop, I never use those features. So it's just a little bit more slim and just gives you the things that you really need. You can't really, I don't know if you can do that for the other systems these days. I'm pretty sure this is just available for Linux. But either way, when you do install Docker Desktop, you'll get all the command line tools and everything included with that. So that will vary. You'll have to follow through the instructions. You'll have to make sure that you install the engine. If you're on Linux, you want to pick your appropriate package manager and use it to install it. At the end of the day, they'll give you some commands to check that Docker is working. And so you want to be able to run Docker commands on your system. And once you can open a terminal or open a PowerShell and run Docker, then you're ready to go. So what we're going to do then is, first of all, we need to take all the software that we have in our image and download it to your machine. That's not a small thing to do, but this is the command that you use to do that. This is a Docker pull, and then you'll have to specify this little tag right here, which is JLPhillips/CSCI:2025-spring. So JL Phillips, of course, is my account, so I'm the one who pushed the image. The image itself is named CSCI, but we make changes to the stack from semester to semester, so there are different tags. And so this is the 2025 spring version of the container. And you can go back in time and pull older versions of the stack if you wanted to, but this is what we'll be using this semester. Now, when I run this command, this is only going to take a second, but when you first start, This will take a few minutes. It's a 30 gig image, and you can tell what images you have by using docker image ls. So after this command completes, you should be able to do that, and you'll find the image listed. I have a lot of other images on my device, so I'm going to make sure that I look at just this one that I just pulled from the list. I'm just grabbing the line that matches that tag, and so there's my image, there's the tag, and I pulled it 8 days ago, but this is, it was made, I guess, from 8 days ago. This is 30 gigs, so just make sure that you have that kind of space before you run that pull command. If you want to remove that, you can always do docker image remove and CSCI spring 2025-spring. So if you run this command, you will remove the image, and that will remove it from your machine. So in other words, that's how you basically install it and uninstall it, and that will clean up all the space. But for now, we want to make sure that we've pulled the image and we have access to it, and that does take a minute. After that, we should just be able to use the docker commands to be able to fire up the image. So I have a command posted here, but I'll kind of show you where else to look so you can go back and find this information again too. So if you're here on the course website, there's a link here to the DockerHub repo. So I'm going to copy that address real quick and flip back over. And so this is where you'll find the container image listed on DockerHub, and it gives you some instructions to be able to know how to pull the image and then also how to run it. So if you do need to go back and look at this, these are basically the commands that I'm reviewing right here. You can copy and paste it in. But I'll go ahead and show you how I'm going to try to run it here first. So this is coming from this. This is just the command that I copied here. So what does this do? Well, you're going to ask Docker to pretty please run your container. You need to make sure that you run that container interactively at a terminal. So that's what the -it command is for. You also need to add this --rm flag. This is mainly a cleanup flag. It just means that once we actually end our JupyterLab session and we stop using the software, which we can do at any time, there are some log files and other things left around by Docker that you can examine to see how the run went. It's kind of this, it's interesting if you develop containers, but we don't need any of that stuff. So this command means that once it exits, it'll clean up all of that for us. So it's just a kind of a cleanup command. This flag means that we need to connect the network inside the container to the network outside the container. Containers are essentially isolated environments. They're like little virtual machines that you run inside your system. So as a result, they don't connect directly to the network unless you tell them where they can connect. So in this case, JupyterLab runs in the browser. The browser has to connect to port number 8888 in order to access that system. So what you're saying is, I want my system's 8888 that I will be accessing with my browser to get forwarded into the container, and you can access port 8888 inside the container. So this just needs to connect those two things together, and then you'll be able to use the link that the app gives you to start it up in just a minute. So we'll see that in a second. If you do have NVIDIA GPUs and they're compatible, so that varies, but if you have an older Mac, you might have an NVIDIA GPU that's compatible. Newer ones, I don't know, I haven't tried much with those. Windows, if you have your NVIDIA drivers installed, everything's supposed to be out of the box working with Docker Desktop these days, and you should just be able to supply this flag, and you'll be able to access your GPU inside of the container. We'll start doing that later in the semester. But sometimes this will fail. We'll see that in a minute, because I don't have GPUs on my system at the moment, so we'll see what happens if you don't have any GPUs. It's really simple to fix. We'll just remove this. But if you have GPUs, you have to include it so that they get also connected from outside the container to inside the container, and you can use them. You want to run as root, so you're running as the root user. When you use Docker, you have to have administrative privileges. You had to have it to install it in the first place, so that's not abnormal. But you need to start up the container using the user root, which is the administrator. And the idea is you're going to grant sudo to a local user called Javian. That's always what you're named when you're looking at this, just means Jupyter. But you become that Javian user, but you want to give that user sudo access so you can install packages and do other things. And this is all the same situation that we have set up on JupyterLab servers. So if you want to emulate that fully, you have to include this little flag here. So both of these, actually. You want to start as root, but then grant sudo. And what happens is the container starts up as the root or administrator. It sets up the sudo privileges for this Javian user, and then it actually de-escalates down to Javian and runs the container as Javian from that point forward. So this is just all baked into the image. You don't have to worry about it, but that's what's happening. It's kind of just magic that's happening behind the scenes. -V is a volume mounting command. So it means that you have to, inside the container, you want access to your files, be able to save files, take files out of it. You want them to be written to your home directory or somewhere in your home directory. So you're going to need to pick a place inside the container where you mount that file system. So we have to attach it. So what I'm doing here is saying that I want my home directory, /home/jphillips, that's my whole home directory, to then be mounted. So this little colon separates. This is the one that's outside the container. That's what files I currently have on my Linux machine. You might pick // whatever. If you're on a Windows machine, you have to find your home directory. On Linux, whatever your home directory is, you put here in this slot. And then you want to keep this other side the same. It's a little hard to read here. Let me see if I can zoom a little more, make it clear. Yeah. So I will be mounting this information here onto this. This is home jobbing work. And this is the place where you want to mount it. So this particular location is already inside the container and available. It's the anticipated place where you're going to mount your file system and deposit your files or use your files. This way it kind of seamlessly works with the container. You don't have to copy files in and out of the container. Whenever you save something in the container, it's automatically saved in your home directory. So we'll get to that, but this is important, right? Keep in mind that you'll have to change that left-hand side to match your directory, whatever directory you want to use, where all your files will be saved that are inside of the system. You also then, after you say all this magic, right, with run, interactive terminal, remove and clean up, connect the network, use GPUs, grant sudo, mount my directory, this is actually the container image name again, right? So you're just saying, run this thing with all of these options. And so at that point, you can hit enter. It's going to give an error from me because I have no GPU on my system. So if you see that, all that means is that you need to remove that GPU's flag. If you have a compatible GPU, that will work and you'll get access to your GPU. If you do not have a compatible GPU, you'll need to just remove the flag and you won't have any GPU acceleration, which is fine. You still get to run on your own system, but it won't be as fast, and you'll probably want to use the GPU systems later in the semester and connect to those. So this is the link. You get two links at the end. Okay, this one's kind of with a special Docker container link. Don't use this one because this weird ID, you won't be able to access that. But the second link, this one will work. So you want to copy that link. If you need to select it and copy it, whatever you need to do, I can just copy it from my terminal. And then I'm going to go to my preferred browser. So I like to use Chrome whenever I'm running this thing. And I paste that into my browser. And then that will connect to the JupyterLab session. So what you'll see then, what you should see is the environment that looks exactly like what we have on our JupyterHub systems that you log into. But this is now running on your machine, your device, right? This is running on my laptop. Now you'll notice there's no files here in this home directory. Usually this is a temporary space. You don't want to keep things here because in this area, there's just nothing there. And when you leave the container and shut it down, those files will disappear. It's temporary, nothing here. But the work directory, if I go into that, that's where all my files are. So these are my files and all the things that I have. So I can put all of my work here. I can open up files and save them, and they'll be available on my device. So for example, right here, right, this is my home directory now. Let's say I want to start up, while I'm in my home directory, a new IPython notebook. So I just click on that little launcher button here, this little plus to get the launcher up, and then I click on this, and I make an untitled IPython notebook. Probably at the top, you want to do some markdown, right? Maybe I'm working on my lab, right? And so this is my Open Lab 1 assignment, for 4850 with Dr. Phillips, right? And maybe I want to put the date. So today is the 23rd, right? So I start off with that. Let me put some spaces. It's marked down, so it needs these extra lines. All right, there we go. So at that point, if I wanted to start working on some things, I can say, this is problem 1 from my lab, and I'll write some code that will answer that particular question. Yeah. And of course, you could do this on the JupyterLab systems instead. And then I'll move on to the next one, right? Do my next problem. And notice what I'm doing here, right, is I want to have all the outputs stored with all the inputs. So whatever code that you do write, this is just something you're printing here. Environ. Let's see what my UI. My user. name is, right? So let's just say I use this. I can save this. This will be, OL A1 JLP, right? So I've saved this. So this would be what you're going to turn in for your assignments, for example. But it's accessible here now, and I can find it in my home directory. So if I look here, let's look for any other pi NDs, right? So that's that file that I just made. And we can, if we wanted to be able to turn it in, just to give you a little bit of a preview, right? Be careful, I want to make a zip file that turns in this notebook. That first argument is a zip file that you want to make. Just be careful that you don't overwrite your file by using the wrong file name here. But if you do that, any files that I add after this will be included in the zip file. So when that gets zipped up, that's my zip, and I can then use that. I can turn that in to the assignment system. All right, so that's how you would work on things. Now, once you're all kind of cleaned up and done, this stuff gets retained and saved on my system, but I can close down the notebook. You want to probably go to the kernels tab, and after you've been running and playing with things, you want to probably shut down those kernels just to make sure that they're all turned off. And Python has been closed down. Maybe exit out of all your terminals. And when you're finally done with your work, you can log in, go to File, and go to Shutdown, and everything will shut down at that point. And so now the browser window becomes useless, so you can actually close it at that point. Come back over here, and you'll see that the process is terminated. Now, whatever system you're using, this is pretty similar. The only maybe other detail you might have to have is if you're running on Mac, you're running on Linux, probably not on Windows, but it's possible on Windows there's a similar flag. Sometimes you have to add this NVUID equals UID flag. This information is available on the documentation over here, just in case you needed to know, right? So sometimes your user ID doesn't match 1000 or Javian, and that can be tricky because then Javian can't write to your file system or save files and stuff like that. So if you have trouble where you can't seem to save files or edit things or make directories, then usually this is the flag that you need to add. And it will then cause your user ID to propagate in, and Javian will have a new user ID that matches your user ID, and then the permissions all work. So there's a little bit of, little adjustment, but once you get everything up and running, it's all smooth from there. And it's much easier than trying to manage 1,000 packages in Python. Now there's one other option. So if you're doing Windows, Mac, you can pretty much probably end everything here. That's pretty much all I can show you for this time. If you are running on Linux, then there's one other way that you could run this. It's just a different way that doesn't require that you have administrative privileges. So if you don't have access to that system, you still have to have the system administrator install a tool called Apptainer. We'll be using this a little later in the semester anyway, because when we log into the cluster systems, we won't be able to run Docker containers because we need administrative access. But Apptainer lets us run things as a regular user. But we do have to change a little bit about how we run it. So the big thing here, how this works, is you'll be using Apptainer instead of Docker to run the container image. It's also a slightly different image. You don't pull it from Docker. I have places online that you can pull this from instead. So I provide the link here on the course website. You have to instead use this thing called a CIF image. And the link is here. So if I sort of copy the link address for the CIF image, the idea would be if you're on Linux, you should be able to have a tool that can download this thing. Usually it's a tool called Wget. Probably familiar with how to install things on Linux. You need to get Wget installed. You can also use curl. It's another common tool, whatever one you need to use. But you want to grab that CIF image. The name here, right, is 2025-113. This is the spring image. This is the exact date, right? So when I actually built the image for the spring. But this is what you'll be pulling, is this CIF image. I'm not going to pull it right now because I already have it pulled in the Apptainer directory right here. And I'm just sort of showing you, right, it's much smaller because it's compressed, so it only takes up 8.6 gigs instead of 30 gigs. So it's a little more efficient in terms of disk usage, which is nice. But it does limit you a little bit. You won't have super user or sudo privileges inside the container, so you can't install apt-get sort of thing. You don't have quite as much control because you're running the container as a user, not as an administrator. But how this works, again, instructions are here. Well, in this case, the way they're not with the Docker image. but I do have them on the GitHub repo information. So not the Docker Hub, the GitHub repo for the container. And so there's a README here at the end, and it has commands for working with Apptainer. You can pull the Docker image and then convert it yourself if you have administrator privileges, but most people won't. So I recommend instead just use the wget command to get this CIF file that I was talking about. And then the command here at the bottom is what you use to run everything. So you can basically, similar to what I'll show you here, you can copy and paste this stuff. The main thing with Apptainer is you first of all need a temporary workspace. So this is where the JupyterLab will stash some temporary files, and then if you decide that you want to install packages, you can install things using pip. In this location, you have to use a flag to be able to do that. I'll show that in a second. But you need a temporary workspace because you need somewhere that the container can write to. This is not where you're storing your files in your home directory or anything. It's just a separate spot where you can install packages and do other stuff. And you can, I've already made this for mine, but you just want to make a directory that will be your temporary location. And then when you're running with Apptainer, it's a very similar command. First of all, you want to make sure that you get Apptainer installed. So if you're kind of looking for this, I'll say, you can go to here. There is an official Apptainer PPA if you happen to use Ubuntu and you want to install with Ubuntu, but you want to follow the get started instructions on the quick start to be able to get some packages installed. I'd probably recommend using the binary packages instead, these releases, but the PPA for Ubuntu and others are there. Let's see if they kind of give, let's see, so you got like downloading images, working with files, over the Apptainer. So in installation, we don't want to install from source. Most of the time you want to install using one of the other tools. So let's see if I can find it real quick. So let's see, it just says installation. They just say, yeah, installing from pre-built RPM Debian, Apptainer, blah, blah, blah. That's all discussed here in this admin guide. So they stay like installation on Linux. You've got so if you have Linux versions, you've got things that you need to do. You can install from pre-built packages. And so there's Fedora, EPLA. There's you can do a GitHub release if you like. You can use Debian packages. There's the Ubuntu PPA listed down here. So these are all the actual places you can install it. And once you do get it installed, then similar to Docker, you've pulled the image. You have this CIF file now in your system. You can use Apptainer to run the container. You do have to use this bind command to put the temporary workspace that we just made. So that's this is the directory I made. I'm binding it to home Javian inside of the container, and that's where all your temporary files will go. You do need to specify this environment flag for your user ID. That'll be important to make sure that things are writable. This will be more, again, depends on if you happen to match Javian, your user ID is 1000, then this won't be needed. It's just because of coincidence. So it's a good thing to include it. This is also sometimes helpful, gives you a little small amount of extra writable storage that you can use in case the system needs it. But this is all running as a user rather than as an administrator, and then you just specify the image that you're trying to run. It'll be very similar to what you saw with Docker. Everything will kind of fire up, and once everything finally gets running, I do recommend running that command in your home directory. Whatever directory you run it from will get mounted as your home directory. You'll get the link somewhere as before. You can take it over to the browser, and now you're up and running. The only thing to keep in mind here is your home directory gets mounted directly. All the temporary stuff is in home Javian though, so you're actually working with Apptainer. It mounts your home directory, runs everything out of your home directory. You're good to go. But those temporary files are actually in home Javian, and I guess they're just kind of some temporary things that it has to create to get things going. But also, if you decide to pip install any packages, you can use this -- user flag. It'll install some additional packages, and they'll go into that directory, into this .local file in particular. So at any point, if that gets too big or is taking up too much space, but the nice thing is that persists. So if you shut down the container after you've installed those packages and you come back in, they'll still be around, and you can use them again. So you don't have to keep reinstalling packages if you decide to use that approach. If you leave off that temporary stuff, you just things won't persist. You'll have to reinstall them every time. All right, so this is just kind of a rundown on how to use Docker or Apptainer to be able to run on your own system. It's the basics that everybody will experience for Windows, Mac, or Linux, but it doesn't cover special cases. So if you do have any special cases, things don't seem to be working, you proceed down a certain stage and then you run into a roadblock, just let me know. We can meet and you can show me where you're running into that issue and we'll get things rolling. You don't need this for the class. And so I want to say that again though. You don't need this for the class. Everything is going to be on the other systems, and I recommend using the other systems. But if you want to do this for a hobby, figure out how to run some of these things. It's not bad to learn, but it's not necessary for the course. Okay, so just good thing to keep in mind. All right, so that's all for now. We'll talk to you guys later.